All right, we're going to work on section 5.5 of your intermediate algebra book. It starts on page 197. All right, starting with example 1. This is solving radical equations. Letter A has the equation the square root of x equals 9. So basically, what number, when you square root it, will equal 9? The idea with solving equations is to isolate x. So you want to get everything off around x, and x should be standing by itself. That means you need to get rid of this radical. When you do, to get rid of a radical, you use the opposite operation, which is the exponent that matches whatever the index is. In this example, it's a 2 because the index is 2. So when you square them, when you square root, they disappear. They cancel each other. And you get x equals 9 squared, which is 81. Now, it is imperative that you check these, because sometimes you get what's called extraneous solutions that actually don't satisfy the equation. So you rewrite the original equation, you substitute your 81 underneath, right where the x is, and you see if it makes a true statement. Well, it does make a true statement, so this is a good solution. All right, let's do letter B. Oh, there is no letter B. It's just example 2. Okay? We're going to do example 2. Solve the radical equation. The cubed root of x equals -4. And again, to get rid of a root, you use the exponent that matches the index. So we're going to use an exponent of 3. And of course, the parentheses are your best friend when you have a negative number over here. This exponent and this radical cancel each other, and we end up with x equals -4 cubed is -4 times -4 times -4, which turns out to be a negative number. 4 times 4 is 16. 16 times 4 is 64. And you should take the time to check it. Some of these things you can check mentally. If I put this -64 back in here, is the cubed root of -64 really -4? Yes, it is. So we're okay there. We're going to go to example 3. Let's scroll this up a little bit. We have the fourth root of x equals 3. We're going to use the exponent that matches the index, and that exponent and that radical cancel each other, and we have x equals 3 to the 4th power. 3 times 3 times 3 times 3 is 81. When we check it, we put that 81 back in there. Is the fourth root of 81 equal to 3? Yes, it is. So we're okay with that. When we do example 4, we have the square root of x plus 4 equals 7. And don't forget, the whole goal when you're solving is to isolate that x. But before I can get rid of this radical, I have to get rid of this plus 4. So I'm going to use a -4. And that leaves me with the square root of x equals 3. And now I can get rid of the square root by using the exponent that matches the index, which is 2. So that says x equals 9. Now I'm going to check over here, because this is a more complicated equation. I probably should write it out. The square root of x plus 4 equals 7. I'm going to take my solution, substitute it right in there where x is. I'll have the square root of 9 plus 4 equals 7. I'm going to simplify. Square root of 9 is 3. 3 plus 4 does equal 7. So this does check out, so we have a good solution here. For example 5, we have the square root of x minus 3 plus 6 equals 10. And again, your goal is to isolate this x. So we got to get rid of this plus 6 first. So we're going to have the square root of x minus 3 equals 4. 10 minus 6 is 4. Now you can't isolate this x until you get rid of this radical, because the x and the negative 3 are both under the radical. So let's get rid of the radical next. Use the exponent that matches the index. So that would be a 2. Then the radical is gone. 4 squared is 16. And now you can isolate x. This looks like a regular linear equation that you've done before by adding 3. And we get x equals 19. Now, we are going to check it. We're going to check it by first writing the original equation, the square root of x minus 3 plus 6 equals 10, and then substituting our solution in where x is. So square root of 19 minus 3 plus 6 equals 10. Now, one thing I do want to remind you of, when you're checking, you do not move things from side to side like we did over here. We subtracted this 6. You're not going to do that here. When you're checking, everything stays on the same side and you just simplify it down. Okay? We don't need to simplify this side over here. We don't even need to mess with this side because it's already simplified to a 10. We're just going to do these operations right here. Do not move things from side to side when you are checking. So what are we going to have here? 19 minus 3 is 16. Square root of 16 is 4. 4 plus 6 is 10. So those two sides are equal, and that means that our solution is good. Come on. All right, we're going to go to example 6, which says solve the square root of x minus 4 plus 5 equals 3. We need to isolate x. The first thing we have to do is get rid of this minus 5 by subtracting 5. So we have square root of x minus 4 equals negative 2. And then we're going to get rid of the radical by using the exponent that matches the index, which in this case is 2. That says x minus 4 equals 4, because negative 2 squared, negative 2 times negative 2 is 4. And then to get rid of this negative 4, we're going to add 8. I'm sorry, we're going to add 4, which equals 8. So we have a solution of x equals 8. We are going to check this solution. You check by rewriting the original equation, square root of x minus 4 plus 5 equals 3, and then taking your solution and substituting it where x is. So that's what we're going to do. We're going to put an 8 in there for x. And then, again, like I said on the last example, you do not move things around from side to side. I'm not going to subtract 5. To check, you just simplify each side down. You do not move things around side to side. You don't need to mess with this 3 over here. It's already simplified, so we're just going to do these operations here on the left. 8 minus 4 is 4. The square root of 4 is 2. 2 plus 5 is 7. Well, guess what? 7 does not equal 3. This solution here does not check out because it doesn't work when I put it back in this original equation. There's a reason for that. It has to do with this negative number right up here and us squaring the negative number and getting rid of the negative. But when this happens, when you check, this is why you have to check. You would never find this if you didn't check. You have to check these. Since your solution doesn't check out, there is no solution for this question. All right, let's do example 7. We have solve the radical. I think that's the cubed root of x plus 7 plus 2 equals -1. And we're going to start by getting rid of this plus 2 over here. That's going to give us, I'm going to subtract 2. The cubed root of x plus 7 equals -3. Now, if you remember the last example, this is where our problem started, by having a negative over here. And that's what kind of contributed to us having no solution. But this one's different. Because it's a cubed root, perfectly fine for a cubed root to come out negative. So this one we're going to get rid of by using the exponent 3 that matches the index. That gives us x plus 7 equals -27, because -3 times -3 times -3 makes -27. And then we're going to isolate x by subtracting another 7. So we get a solution of x equals -34. All right, we're going to go over here and we're going to check just to make sure. And we're going to start by writing the original equation, the cubed root of x plus 7 plus 2 equals -1. And then we're going to put our solution of -34 in there where x is. So the cubed root of -34 plus 7 plus 2 equals -1. And we're going to simplify, and I can't say this enough times. Don't mess with this side that's already simplified. Do all your operations on this side. You do not add and subtract and use opposite operations when you're checking. So -34 plus 7 is -27. The cubed root of -27 is -3. And -3 plus 2 is -1. So these two sides do in fact check out. So this is actually a good solution here.